Welcome back to the official CABSAT podcast powered by Northtelecom. Joining me now is Joakim Espeland.
Yes,
right?
that's correct.
And you're the CEO of Quadsat.
Yes.
So why don't you tell our audience a little bit about yourself and what Quadsat is?
Okay. Yeah. I'm electrical and mechanical engineer, and I started Quadsat 7 years ago together with a co-founder that I met at university. I had a long background working in the telecommunications sector. At the end of it, I was working a lot in the oil and gas sector, maritime sector, and found that the satellite connectivity satellite antennas could probably be tested in a better way. Drones were emerging at the time, and it seemed to me like an obvious blend to put drones with the RF sensors to be able to basically see the radio spectrum and see what's going on there with a much more detailed analysis, as you would do in a laboratory already. But now you could suddenly take this capability out into the big world and look at larger antennas, different types of antennas, installed antennas, and so on. So that's basically what we do a little bit in a nutshell. And yeah, I think we'll get back more to exactly how in a minute.
Okay, so why is antenna testing so important, and what impact does it have on satellite communication?
So antenna testing is important for the same reasons as testing anything is really important. You want to make sure that what you're doing is going to work, and you want to make sure that it works the best that it can do. Antennas are a little bit special as well, because everything it does is invisible, right? You can look at an antenna and you wouldn't know if it's on or not, right? So basically, being able to see what's going on beyond what has happened from the antenna leaving the factory, right? So if you imagine a ground segment antenna today, it can be anywhere from 4, 5, 6 meters up to 30 meters. Those are quite significant installations to undertake when they come on site. That might not work exactly the same as you had predicted in your simulations or as you were building it up. But it's also really difficult to test such an advanced equipment, and that's where the drones make it very easy, right? You don't have to go onto heights and all of these things. You just fly the drone and you get the data, and there you go.
Yeah. All right, great. And what are some key challenges the industry faces when it comes to testing antennas?
So I think probably one of the biggest challenges that we're facing right now is the flat panel antennas, right? Because for the history of satellite communication, antennas have been parabolic, and that's been the only it's been the only type of antenna that you could get is a parabolic antenna. So all the standards that we have on antenna on antenna performance and how they should perform, it's all based on parabolic antennas. The flat panel antennas just doesn't work the same way. They're a completely new type of antennas that has multiple electronic elements that then can steer the antennas, and there's a lot of benefits with that, but there's also some. So why do we have parabolic antennas in the first place? Because they make a lot of gain, right? And they make gain exactly where you want it to be, and that makes a lot of sense when you have geostationary satellites. But now that the satellites are moving and everything's dynamic, and you might want to do multi-orbit and these kind of things, flat panel antennas are much faster. They're smaller. You can get them in places, but it's a new kind of dimension of when it comes to testing and the performance, because the performance of a flat panel antenna is different for every look angle that it's looking at, and that's the big challenge basically.
And why don't you tell us a little bit about what antenna verification is, because I noticed that's something you guys also do.
Yeah.
Does it go hand in hand with the testing, or is it something separate?
Yeah, exactly. So basically so antenna verification for us is really being able to help antenna manufacturers, antenna installers, and service companies get on the network as quickly as possible. So they have to comply with what satellite operator sets as their standards, and then satellite operators has to review the performance information about each antenna and then decide does this fit to the link that I'm trying to design? Does this fit to what I'm trying to have? So Quadsat is trying to work in between there and helping the satellite operators get the data that they need and standardizing so they can easily accept new antennas onto the network. Meanwhile, a satellite or an antenna manufacturer or an installation company gets very clear instructions on how to get on the network, because now it's a little bit different from all the different satellite operators. Somebody's unsure, and it depends a lot of which contract are you on and so on. So it's a little bit unclear on exactly what is the road, and that's why what our job is to fix.
Interesting. And I noticed you touched base on drone technology. So what impact does drone technology have on this antenna testing and antenna verification?
So for us, we see the drones as a mode of transportation, basically, right? We have a sensor that is unique and can capture specific data, but we need that sensor to hang at 100 meters height somewhere. It's a mode of transportation, but it's also a flying robot in that sense that you can pre-program it to do exactly what you want to do. So if you were working with our solutions, you would know that you never actually fly the drone. The drone flies itself. It takes off itself. It goes out, and there's no pilot that could do exactly, because it needs to fly at the exact same places, and it needs to do that over and over again. So you get repeatability in what
all that data.
Yeah.
Analyze the data
exactly.
effectively. Okay, interesting. And what challenges does your company address, or opportunities does your company address in the industry?
Yeah, so it's really about increasing throughput, right? So making sure that we have as much throughput on the satellites as we want. We deliver the best quality that we can to the customers. We ensure that we have as much uptime as possible on the network. So this is basically what we're building, a very easy way of doing. And one of the things that we also do, and we do that quite a lot, is that we come in and we look at, okay, how does an antenna perform? And that wasn't exactly how it should be. But that data that we then provide to our customers is so good that they can use that data to calibrate how the antenna should be. And then we actually get to not just measure, but we actually can be part of the calibration process and make the antennas work better. And this is ultimately saving, as a service company, it's saving you money, because suddenly now you can get more throughput, more out of your capacity on a smaller antenna that you could before. As a satellite operator, it's guaranteeing you more availability, better performance, better quality of service. And as a manufacturer, it ensures that you're able to sell on your products to any satellite network, which makes it much easier for you to go to market.
Okay, great. I guess that's pretty much it from me. Thank you so much for joining us, and we wish you a great show.
Okay, thank you. It was a pleasure to be here.
Thank you.